Hello, welcome to Sean Builds a Lisp. My name is Sean and I am building a Lisp. In the last couple of sessions, I was going through and kind of top down working with what I want my macro expander to look like. This session I thought I'd kind of shift gears a bit and think about things bottom up. What does the compiler look like working up towards the expander? And really just kind of at the point now where we can read forms, we can manipulate them, and so really just kind of experimenting with the direction that I want to take this language. So let's get started. All right, where shall we go? I'm gonna go to compile.js here, and actually, let's just check out a new branch. Let's call this compiler experiments. And that way, what we can do is we'll probably want types. Let's just clean out that code, start totally fresh. Okay, so what I am gonna do is pop over to my reader and just kind of check what the status of this is. All right, so I think, great. Okay, so what our reader is doing is essentially just spitting out JavaScript objects for all of the primitives. So rather than parsing a string, it's going to do object.assign on the string that it parses so that we get the string class object. And I think that's how I want to do things. So let's just start by having a compile function, and it will take a form. For now, let's just return that form. All right, so I'm just gonna kind of play around in a comment here, thinking about what this might look like. So let's just kind of take our prototypical example. So what I had been writing is get for member access, and then something like console, and then a quoted symbol, meaning direct member access, not computed. And then we would kind of do something like that. So I think what was getting me hung up before is dealing with this quote, because I think really quote should probably be a core function, and I was trying to deal with it inside of a macro. And the reason I was trying to do that is to kind of make it feel like this member access is actually evaluated, and so it would kind of resolve console to the console object, and then you're trying to get something by a key, not a string key. And so like by kind of thinking about this quote as being evaluated, you would end up with a symbol afterwards. Whereas if you were to think about it being evaluated like this, it's kind of, so this symbol log would be resolved to whatever it was bound to, and so you would be getting what it was bound to, and that's kind of like a computed property access. And that kind of makes sense, but it's difficult to do in a macro if we want quote to be a primitive form, a core form. Another kind of thing that I was thinking about is I was trying to basically make something like macro expand quote, and then some form essentially equivalent to the form itself. And so basically expanding a quote would be a no-op, but I don't think that that's actually the way that things should work. I think that what should really happen is if you were to think about eval and you were to eval a quoted form, this would evaluate to that. So just kind of, so this should not go to that, but instead it should actually go to quote plus 1, 2, because I don't think quote should be a macro, quote should be a primitive form. And so raises a few questions that we have to answer and how we want to go about doing this. So let's just type out some other things. And so what I'm really doing here is just, before I get started on the compiler, trying to think about what should this compiler even compile. So if we were to do something like function foo barbaz and so one thing is this isn't quite a Lisp yet. We are representing JavaScript directly, so we need a return there and a block. And once we have the core forms, we can then clean these up with some macros. So basically, I would expect this to compile into a JavaScript function, just pretty straightforwardly. Something like that. And then so then there's kind of like a var where you might want to do something, set the string foo to the variable var. And this is actually not really what this would look like. If we're representing kind of possible things that you could do, I think it would be more like define foo and then maybe something like this. But you could also, we don't have an object reader, but let's just pretend we do. So if you were to do something like this, that should also be doable. And then maybe this is, I'm gonna just make this foo to stop any confusion. All right, so let's do this. So we would also want to be able to do that, and let's clean this up a bit. So, and then so these are the various destructuring forms. Would be the various destructuring forms. And there can of course also be an assignment. You know what? I am so used to, I think that in JavaScript it's very common to put spaces inside these guys, but kind of in Lisp-like languages it's not. So let's get used to that. And then the other thing you can do in JavaScript is basically give this default value, and this format's already a lot to parse. I don't know, maybe we could make it look something like this. So basically, if I delete this because, so basically I think we could get our reader to fairly easily start reading, see a colon, and then do something special at the end. For example, read the next form and do something with that. But if we were to do like colon and then equals and all that stuff, I think it's getting a little too far away from Lisp. This is kind of a balance that we're going to want to, we'll walk tightly. Because we want this to feel both like JavaScript and a Lisp, and there's going to be trade-offs that we have to make. So basically what I was kind of thinking is that maybe this left-hand side of the assignment could be a form in and of itself. Maybe it's like something like that, kind of mathy, or we can come up with some other symbol or what have you. And then So something like that. So what else? We can also destructure into an array. So we would want that to work. For example. So basically, the first element of the array would be bound to foo, second to be bound to bar, and of course this, actually, can that take defaults? Let's pop over to some documentation. JavaScript destructuring, and let's just find that on MDN. Okay, so yeah, you can also have destructuring there. So maybe this would be more like this, so that we could then basically have this would always evaluate to a kind of destructuring macro. Something like this. So basically this would assign default values to everything. Maybe this is really just shorthand and we have kind of a colon as a first class macro. All right, so I'm gonna go over to AST Explorer and just kind of start playing and seeing what Babel actually generates for some of this stuff. Actually, let's just get these two things side by side. Whoops. Okay, so basically we just kind of want to repeat exactly what we have in JavaScript, what we expect this kind of thing to compile to. Okay, and then we've got bar foo equals bar. Sorry about that. All right, so this is var foo equals foo, comma, bar equals, or sorry, yep, bar equals bar. We have baz other equals baz. And this would be baz other equals baz. And then we've got foo equals foo. Bar equals bar. Baz equals baz, and that is equal to foo bar. Yes. Okay, so I'm just gonna kind of take a look and see what we have here. And so we have an array pattern, and so this is an assignment pattern. Left and right. Okay, that's interesting. Okay, let's take a look at this example where we have an object pattern and we have properties. We have object property. We have our identifier, which is the baz. And the value is an assignment pattern. So basically, if we were to map this, this would actually look something like this, right? Oops, not that one. And then, actually, before we do that, let me take a look at this object pattern here. And it's just an identifier. Okay, cool. So basically, rather than doing it like this, I think what this would actually look like is and then that's consistent between both object destructuring and variable destructuring. And super cool bonus, we can use basically an object expression for object pattern as well, I think. I think that should work. So that's cool. But if we look at this, what this whole thing, so basically this entire stack here is actually a variable declaration with a set of declarations that are each element is a declarator. You can see that a declarator has an ID and an init. And so the ID is basically the left-hand side. So basically kind of what I'm getting at here is for array pattern, I think I'm actually going to thinking about essentially overriding like an array. Like in a so if we were to represent an array, right here I've got kind of a syntax, this syntax, but maybe it's actually like this. So it's just another S expression, and we compiled that down. So, oops. And now the problem with this is that it's a bit ambiguous. It's totally dependent on the context of this var, whether this is an array. So, not sure. And similar, this would be actually object. I don't know, we'll say property for now, but it'd be great if we could come up with something better. Balance my parentheses. They're not balanced. What do we have here? This guy should not be there, and then that should be there. Okay, so this is a bit verbose, and we would clean this up with other macros and reader macros, so that this isn't what we're directly writing, but kind of what I'm playing with here is what would the core forms look like, and basically by going about it this way, I can kind of map core forms directly to Babel constructor functions. And so not sure this would actually be like declarator, but I think variable declarator is only valid here, so I don't know, maybe we can just skip that, and maybe it's really just macros all the way down, and this define just knows to call the right thing. Anyway. Let's think here. So what else? In this function, we have this bar baz here. And so this is actually a call expression. So if we jump up there to our function declaration, we can see we have a return statement and a call expression. Not so sure how I want to deal with this one. So it's kind of interesting. I think that I'm almost tempted to say that the core form for that should actually just like literally be call. And so basically by doing that, the head of any compilable form should be in the environment. Okay, so kind of talking through all of that, I think that this is kind of the way that I want to go. So basically, for each form that will compile into Babel AST, I want that to be a function in an environment that compile has access to. So this is going to end up looking a heck of a lot like our expander from before. But who knows? Maybe we'll just have macros all the way down after all. I don't know. Or maybe it's more like we essentially have two macro expansion phases, one dealing with S expressions and then one generating code. And they'll be fairly similar, but let's see. Okay, so as usual, I'm just going to put a stub resolve function in here. So we're going to resolve form, and I'm just going to do something kind of stupid and turn form and n form dot value of. So basically, if form is null, we don't want to call value of. So if it's null or undefined, we'll just get null or undefined back. And then the value of should essentially resolve to a symbol. Our env will be basically an object made up of symbols. And so when we look up a symbol in our env, we'll either get undefined or a function. So let's say, let's grab our so const compiler equals resolve. Actually, let's check. Is it an array? If it's an array, we will check the first element of the array, and that should be our compiler. If it's not, it's an error. Yeah. Okay, so we'll just do resolve form and env. Okay, so all right, so if not compiler, I'm just gonna error for now, and we can throw an exception when we try to call it. Not a function. No, that's all right. We want that. We want that guy. Okay, and we will return. So similar, we'll just call the compiler with the form and the env. Okie dokie. Otherwise, let's switch on the value of the form. So what do we have? It's a symbol. We're just going to return the identifier for the symbol. The intern symbol. All right, so if it's a string, we will return t.string literal. This should look fairly similar. We've done this a lot. Yeah, let's just keep going. If it's a number, return t.numeric literal form.value of. Real quick, I'm just curious what not a number is gonna be. Let's just do Okay, so not a number is an identifier. So let's just also infinity is probably an identifier too, huh? Yeah. Okay, so I'm just gonna pop up a node REPL. Just realizing this might be a little small. I'm gonna zoom in. Whoa. Okay. And so let's just see. Type of nan is a number. Type of infinity is a number. Oops. Sorry. Oops. And we want to actually dig into this. So basically, I want to make sure okay. Okay, that's great. Okay, so basically infinity and not a number are going to be type of number. So we need to, I think those are actually going to be symbols for us, given how our parser works. So I think that's fine. Let's continue. Oops. All right, so. All right, so then what else can we have? We can have undefined. So we want to return an identifier for undefined. And in the case of an object, so objects are gonna be a little tricky. Let's just pretend that they're not, though. All right, so if the object is null, all right, so we want to just check. All right, so if it's a form, then we will object expression and VS Code autocomplete has gotten slightly aggressive recently. Anyway, I'm just gonna map these. What do we have? We want to key value. We'll just map these to be object property, and key will be, we'll just call compile again with key. Actually, all right. I'm just going to throw an exception because I don't know what I want to do with objects yet. Maybe object won't even be in our AST. So if object exists, and otherwise we have a null literal. Okay, so let's start making our environment. All right, so let's start with a call, just so that we can, as usual, let's get to our little hello world with this. This is gonna look very, very similar. So given a call, we're gonna get a form and an env. And so what we want to return is a call expression. And callee will be form 1. So we want to compile that guy. And then we'll slice from the second element and map that with compile subform env. Okay. So we have a call. So now we come back to the good old get. So I think what I'm gonna do is cheat and make dot non-computed member access, and a computed member access we'll call something else. Okay, so object will compile form 1 in our env, and this is interesting. So the property will actually kind of have an end from the object, but I'm gonna ignore that for now. So we can just continue on, and then computed is false for this guy. And so this is where before I was doing this kind of quote thing, which still not sure if I want to do that, but at any rate, a dot will be fun. Okay, so let's just fire up our reader. Let's just grab that. This is just kind of, we're just making this up as we go along, so I'm not too worried about code format. And we'll just grab that from read. So now we can just go ahead and read. Let's do this, dot console log, and we will give it the string foo. And let's just log that out. Okay. Actually, let's just do node, and where are we? We're in compile. Chances of this working first try are slim to none. If it even runs. Okay, what's happening? excuse me. We're gonna so currently in the stream, the the period character is the current element in the stream. So we want to basically, let's just assign that value equals that, and then next is going to be, we'll peak. All right, so then if next is greater than or equal to 0 or less than or equal to 9, then we'll read number with our stream next and value. Otherwise, we're going to read symbol with our stream next and the value. Okay, so we need to go grab read symbol. And I'm just searching and replacing number to symbol here. Except I think that's not in the same place. Read symbol is just at the top level. Okay, so now we should be able to read our dot. And so in our compile, our dot will basically be this form, and get will be the computed version. Oops. I have no idea what optional means. You know what? That might be like kind of safe member access, something like this. Oops. I wonder if AST Explorer will do that for us. Interesting. Okay, so we're still in Node. I'm just gonna call it. Let's just assign it to a variable. It'd be way easier. Okay, so we're just gonna do this in line here. Member expression, come on, expression. Okay, let's just gonna copy this so that we can get generate. All right, let's just go ahead and generate this and see what kind of JavaScript we get out. Okay. That looks the same. Okay, this is going to get interesting, but for now I'm just going to ignore that whole optional field. It looks like the JavaScript I get out is the same. Actually, let's try this. Let's try turning this into Let's call it optional member expression and see what happens. Okay, well, it seems, what happens if we call that with false? Interesting. All right, I'm gonna ignore it. Okay, so now I'm gonna get to quote. All right, and so I'm putting this here. So quote's gonna be a core form. If you call expand on a quote, nothing will happen. It's not a macro. It is gonna be a slightly complicated, actually I'm gonna make a function. This is gonna be recursive. Okay, so if, oops. I think I'm going to call this compile quote. Okay, so if we have an array, so this is the crazy one. So basically, if we eval quote, so basically what we're looking for here is basically deep equal eval compile. Actually, eval will kind of just, anyway. All right, so if we eval compiling our quoted form, that should deep equal a not quoted form. I mean, so this isn't quite accurate because our reader would actually assign different source locations here. But I don't know how to write it any better. Whatever. Anyway, the idea is that once you've compiled and evaluated a quoted form, what you get should be the quoted form verbatim, including source locations. So this is going to be quite fun. Okay, so basically what this means is this will be, we want this to essentially expand to all right, so quote one should just expand to object.assign. And so basically this is compiling into JavaScript. And so the reason this is kind of weird is because we have the number at compile time, but we need to compile it to JavaScript such that when that JavaScript runs at runtime, it has the same value that we have at compile time. Crazy. Yeah. So basically, okay, let's start simpler. And this is going to look a heck of a lot like our compile function that we just had. Type of form dot value of. So we're going to start with the primitives because they're way easier to think about because they kind of bottom out. So compile quote. Let's just start with a string. Okay, so this will be basically what we want this to do is object.assign, and I'm just going to kind of write like a weird quote type thing. Maybe I want to use Babel quote. This will be way clearer. Okay. And then this would be unquote value of. I'm just organizing my comments here as usual. All right, so okay, let's just start with that. Okay, so we're gonna return a call expression, and the first object, so the callee is object.assign. So we need a member expression, and the object is object, and the property is assign. Great. Okay, so we're calling object.assign with, we want this to be a string literal. Okay. Okay, so that should basically give us up to here. And then arguments. So arguments are in an array. And so the second argument, we'll basically want to do the same for all of the property keys on the string. So we can do object.entries. Oops. Form. Oh, that. And these are the object properties. So we want to first do the object. Oops. Dot object expression, and this will just take an array of properties. So we will map those from the entries on the form. So like usually we have key and value. So t.object property. Okay, so the key is going to be an identifier for key. We're just going to assume everything's an identifier now. It might not actually be true. Missing a parenthesis here. All right, what else do we need here? Value. So value. Actually, let's make this recursive. This will be a bit. All right, I'm gonna jump over to the Babel documents. I know that they have some things that might help me. They have some things that are helpful. Let me see if they would help me. Nope, I think we're just gonna have to do this the hard way. It's okay. I'm just gonna do like compile meta or something. Okay, so type of, I'm gonna call this meta. Okay, so these are the keys that are attached. So these are more clearly JavaScript primitives rather than our weird AST JavaScript objects. All right, so basically if we have an object, we want to do this. Alright, we want to check if meta exists. We want to do that, otherwise it's going to be a null literal. Okay, so if it's a string, this is going to be really similar. I'm just going to repeat everything because I'm not sure that things will stay similar. I want to actually return that, don't I? Okay, and then we're just gonna, oops, we're just gonna repeat that a bunch and change it. Number to numeric literal, and then boolean to boolean literal, symbol, and this will be actually object dot assign, and nope, t dot call expression. The object is going to be symbol. Property is 4. So we're basically taking a symbol that we have and turning it into symbol.4. So we need a member expression around this guy. Okay, so we're calling symbol.4, and what's the value? We need to give it a string, so this will be a, actually we can probably just, let's just call this again. Compile meta, and so this will basically loop back to a string literal. Symbol.key for, and our meta. Oops, and those are arguments, so they need to be an array. And undefined is a symbol t identifier for undefined. All right, what else do we have here? We need to check if it's an array. Yeah, and I don't think we don't need an env on this guy. All right, so if it's an array, we're going to return array expression, and that will be okay. So and we need to wrap this in an object expression. All right, object property takes a second parameter, which is the value. So we will compile that down. Okay. So basically what this will do is basically lift any arbitrary JavaScript into Babel AST. So for compile quote, what are we doing here? actually, this might be way simpler. So we can compile meta form dot value of, and then compile meta on the form itself. Okay, I think this is on the right track. I think I'm happier with the direction we're going now. Okay, just kind of thinking through how this might work, and I think that this is pretty much. That's pretty much right. Let's see here. I'm just going to do something weird. I'm going to just quickly test some stuff with arrays. Might as well just go for it. All right, so start is going to be line 0, column 1, and end we'll just say is line 0, column 2. Okay, now I want to call object.entries on this. Oh, crap. It just, oh shoot. This is a problem. All right, so I don't think we can actually just call object assign on this. Okay, so this is basically by calling object assign on an array. I think that we're essentially just turning it into an object with okay. All right, ST is not good. Okay, we need to do better. Okay, so Okay, so I just kind of went into thinking mode. Let me kind of explain what's going on. So basically, with object, if we object assign to an array, our assignment ends up being an iterable part of the array itself. So you can see here, I object assigned and then mapped, and we logged out this weird undefined thing because we have a weird key. So we can't store this stuff directly on the AST nodes themselves. All right, two solutions. We attach some stuff to the global object in the compiler environment, or we go back to having kind of syntax objects and whatnot. I'm not sure at all. I really liked being able to work with these S expressions just as arrays, indexing them. But this kind of puts a damper on things. Alrighty. Well, that was fun. I don't think I'm gonna be able to solve this live here. Well, I guess it's a good thing we're doing a lot of experiments before we go and write too much code. So let's see. We'll be back next time, and let's just kind of talk through what we think we're going to do here. So let's just take our prototypical example, get, well, not dot now. Whoops, whoa. VS Code is freaking out. Okay. Dot console log foo. How can we represent this? So the way I was trying to represent it right now is basically object.assign. We have an array where the first element is also object.assign, and it is an array. And it's object.assign symbol for dot location start, etc., and so on and so forth. So basically every little element we would assign some metadata to the object. And this doesn't work because we're totally trashing our arrays. Our arrays don't work anymore. So alternatives. What I had done when I started this whole project, I was actually parsing S expressions into Babel AST directly, and then we were kind of working with that from there. So we could go back to that. So this would be like type call expression, object is type call expression, and then we can just attach the location info and whatnot directly. Object, oh. So this is where it kind of got weird. Maybe it's not that bad. So this is type identifier, name is dot. and then we would have our source location attached, just like Babel would, etc. And then basically what we would do then is take our form, we would call like syntax to datum on our form, and then that would give us it would kind of expand it to the array, where it's like, okay, let's make an array callee and then arguments, and then we could access them by index. This might not be that bad to do again. I mean, we could also make kind of shorthand things for this. For example, if we wanted to do first and on our form, we could basically compile this first into like check the type and then do some smart stuff. Or we could do something like form and then some kind of dereferencing thing. I don't know, at dot 0, I don't know, something like that, and then at, I don't know, dot value of, or who knows, I don't know. Actually, I guess in this case, 0 at, so that looks pretty goofy, but I suppose it would work. So basically we would take our form and then the at symbol would essentially unwrap it so that you could access the 0th element, which in this case is another form. So we'll unwrap that and access the 0th element, which is the dot, and then dereference that and get, or I guess we would want that to be a symbol, but this would basically be kind of like a shorthand for syntax to datum. And then this could just directly, so if we like make some kind of macro first, and then I guess it would actually be a function, but first, call first on a form, like we can look, and so we know that this would be callee in this case, and maybe if we had an array, we could say that this goes to first form dot elements 0. I don't know, we could kind of do something like that. But it would have to be a function like this because we can't arbitrarily index into TypeScript. We can, sorry. If we wanted to try and trap numbers, so if we have a call expression, it has an object and then arguments, right? Arguments is an array of stuff. We could wrap this in a proxy, and so then if you do form 0, this would call our proxy trap, but that would probably be pretty darn slow. Okay, so that's one option. We go back to just using Babel's AST. We parse directly into Babel AST and go from there. One cool thing about that is I wonder if we would, yeah, we would still need to do a lot of processing on the way down because we don't, I mean, we're gonna do something like define var like this, right? And so like we can't just parse this directly, and as we're walking through call expressions, we need to check if they're actually macros and all that stuff. So we would still need, this would still be pretty wonky. I think it would work. It's just kind of tedious, and it's not too different from how like Racket, I mean, it might not be that different from how something like Racket would actually works. But I really would like this to feel fairly Lispy. So another option is to basically keep like a look aside table. So we could do like we could use a weak map. And so basically as we parse our AST, we can stick with the kind of string, sorry. So we still need object.assign for symbols, basically to lift them up into objects, I guess, at this point. All right, let's just continue. Symbol for dot, and then etc. etc. Actually, I can probably just that doesn't need to be in a comment because it's actual JavaScript, huh? Okay, and then this guy is log. So that's our member expression, and then what do we have? We want new string foo. Okay, so basically that would be our AST. Okay, so we have our AST like this, and basically as we read it, we can just kind of assign stuff. Let's just make a function with meta, and then we'll take a form. So we can say, and what would that function do? It would say meta dot set form oops. Let's call this meta map just so that we can do this. All right, so set, form, and meta. And so basically we still need to keep all of these things as objects. So that we could assign them onto this weak map. But the problem with this is, oh man, this mouse wheel stinks. I still haven't bought a new mouse. Okay. Okay, so we need to go through and call with meta on all of these guys. I guess the problem is we need to compile this down to JavaScript, and I was really hoping to avoid messing with the global or putting any kind of requirements on. So compiling the quote would require access to this this weak map. And yeah, so the problem there is we could compile this down, but until it's actually evaluated, we don't have a reference to any of the objects to store in the meta table. So we actually need to kind of mark them. Oh, this is not quite, sorry. I just got distracted by my code up here. It was wrong. That's what it should look like. It's still wrong. I don't know what's happening here. I need to close that. That's what that should look like. Okay, so I guess the whole point, maybe the whole point of this is that we're compiling this stuff down. So we could just do something really dumb like make with meta a macro kind of thing, and just wrap all of these guys. So we would basically call with meta on our form, and then we would give it all our crap. And so basically the metadata we would essentially need to be able to compile that to like primitive Java objects. So basically this would come out and immediately, so when evaluated, yeah, I'm not really sure. I guess the other, oh no, yep, shoot. Okay, anyway, so I guess how long have we been going? About an hour and a half. Since we're stuck, I guess we might as well call it a day, and we'll come back and think about this in the meantime, and we'll come back and we'll figure something out. Just need to make a decision. Anyway, as always, thank you for watching, and until next time.